Our cs51 final project was developing an AI playing agent for the board game called Corridor. The group members are Sam Feingold, Adam Radijak, and Stephen Wang. Our motivation for tackling Corridor is first that this is a game of interest. At least one of the group members has played this game before, often with his dad. Also, the game has not been solved, making it a game of research interest. And finally, it strengthens core concepts that we've touched on in cs51, such as object-oriented programming skills that we started in problem set 7, and exposes us to two major algorithms, minimax, which is often used for gameplay, and a search algorithm called breadth first search. The data structure that we use to represent the board is an array of arrays using Python's NumPy package. An alternative to this would have been an undirected graph. However, we had issues using this representation, namely in how we would place a fence between two fences, a corner case that we were better able to circumvent using an array of arrays. The algorithms that we used were breadth first search and minimax. Breadth first search scans through possible moves and returns the shortest path. Minimax is an algorithm often used for game playing. It assumes that both players are rational and then builds out a game tree until it either hits a terminal node or a given depth. In our case, because of the very large branching factor in Corridor, we use a depth of 1. Here we see an example of gameplay. The blue agent represents a min-max agent, and the red agent represents a random agent. The blue agent moves straight across the board to the other side as it's supposed to, whereas the red agent places fences randomly. Moves speed up as fence moves are eliminated. Eventually the blue wins. For our results, we found that checking legal moves is quite expensive. It takes about 5 seconds per player to check all the legal pawn and fence moves that can be made in each turn. Also, we found that minimax agents do better than the random agent, as you could see in that video where the blue player was moving directly towards the other side. Because of the depth being equal to 1, our minimax agents are making short-sighted moves. With more time, what we would like to first have done is investigate alpha-beta pruning to extend the depth of our minimax tree and to speed up our decision processes. We'd also like to use increased game knowledge to eliminate needless moves, and would like to come up with an alternative to check the legality of fence moves, namely looking at whether or not a fence completely blocks in a player, because that is an extremely expensive computation. Alright, that's our project, and we hope you enjoy testing out Corridor.